Okay, welcome to lesson 20, multiplying and dividing rational expressions. Okay, so for this one, it's actually not going to be that much different than simplifying, especially when the multiplying, the first part we're going to do. So here is kind of a, a simpler example of something we're going to do. So for the most part, though, this kind of confuses people sometimes. They say, okay, this times this, what am I going to do with that? You can really just sandwich these two things together. It would be the same thing as if this was all just over, right? So this is just 3 times 2m over 5 times 9. Same thing, right? Now, the only thing that we need to do now is we can simplify this a little bit more. So again, I've got a 3 up here and I've got a 9 down here. You could really just simplify that expression and just ignore the 5 and the 2 for now if you wanted. You could also multiply 9 times 5 and then 3 times 2 and then simplify that. But so there's a few ways to do these things is kind of what I'm getting at here. One, I'm going to show you a new kind of method that we didn't really do last time. If I rewrote this expression up here, if I rewrote this as 3 times 2m over 5 times, and we wrote it like 3 times 3. Well, if we did that, now you can see that I got 3 up here and 3 down there. What I would have left is just going to be 2m over 5 times the 3 that's left there is 15. And that would be my answer, because I would normally have to say where m is not allowed to be equal to. But if I go back up to the beginning here, x or m is never even in the denominator, right? I could plug any number I wanted to into m. It could be negative infinity or negative whatever, or positive whatever. It can be anything, right? So m's allowed to be anything, so there's no restrictions. Okay, so I'm going to let you guys go ahead and do number 2. Yeah. Okay, moving on. So looking at number 3 here, let's just do another one. Like I said, what you could do too, I'll show you this method too, just so that you see it's the same, is just multiply the numbers on the top and the x's on the top and the numbers on the bottom, and just rewrite a new expression. So this could be written as 50x squared over 12x. Now we've got just what we had in the last lesson, right? Where you've just got numbers you have to simplify and then x's that you have to cancel. So looks like 2 can go into both of these. So I could rewrite this as 25x squared over 6x. And then the last thing I can do is I can cancel one of the x's in the bottom. So this would be written as, like, one of these x's up here would cancel with that one in the bottom. So this would be 25x over 6. But now, looking back up to the original question, so that could be this point before we canceled anything too, right? Or that one. X is in the denominator. So if x was equal to 0, that would make the entire thing equal to 0. So you'd say where x cannot equal 0. Okay, dividing. Dividing is almost as easy as multiplying. There's a couple little tricks. I'm just going to go over here for a second and just kind of see if you've seen this before. If you go, I don't know, like 4 over 7 divided by 2 over 3. Well, dividing by like something is the same as multiplying by the inverse of it. So remember, inverse just means like flipping it upside down. So this expression that I have right here, that's the same thing as going 4 over 7 times and then just flipping these upside down. So 3 over 2. So you just flip those. Now multiplying these fractions is really simple. You just go straight across, right? So 7 times 2 is 14. You got 12 up top. You could simplify that to be 6 over 7. So that flip is the only difference that we have with dividing. So if I look over here, I've got 6x over 7 divided by 8 over 4x. I'm going to flip these and multiply. So I'm going to rewrite this as 6x over 7 times now 4x over 8. Now I can treat it just like my other ones. You could either combine these, like, the 6 and the 4 and make that 24 and the, 56 in the bottom and then simplify. Or I can see a pretty simple fraction right there that I could simplify. Let's simplify that. So let's rewrite this as 6 um, x, if you want to leave it the same way, just times, and then this becomes 1 over 2. So just x on the top now, over 7 times 2. And I drew this line in the bottom straight across. It didn't matter. I could have also just kept it like looking more like it was before. It could have been 6 over 7 times and then x over 2. Same thing, right? And if you want to do that, now we can probably simplify this without having to cancel anything again. So this would turn into 6 x times x is x squared over 14. But now what are my non-permissible values? Well, x is not allowed to be. Go back up to the beginning. Even though we flipped this x, up to the top, like the x is up there now, we go from the beginning stage though. So at this point, x was in the denominator. So you can't divide by 0 there. So in that original expression, x is not allowed to be 0. Okay, moving on down. Okay, so we got some questions where they've already been factored. You can kind of see that the tougher part of this would be as if you had to get it to this point, but it's already like at this factored point. So now, what do we do? Well, like I was saying, as soon as you see that division symbol, easy fix, you can change that to multiply if we just flip these two upside down. So let's rewrite this as 8 over, well actually we're at the bat too. Why don't we just cancel that 8 with that 8? You can do that. You got 8 over 8 and like just sitting there ready to be, canceled. So that just becomes 1 up top now. So 1 over r minus 3. And now instead of divide, I've got multiply and then flip those. So up top I've got r plus 7 times r minus 3. On the bottom I've got 7 times r plus 4. Now you might be saying, well, that didn't help me because I've got r over 3 over here, and I've got r minus 3 over here and r minus 3 up here. But they're in different like spaces. I can't really cancel those, right? Because they're like two different like terms or something. But no, like remember when you're multiplying, you can just like sandwich these things together. So this is pretty much the same as just drawing this right across, right? You've got all, just like before now. You've got, this is all just one big expression. So we've got r minus 3 up top. You can just cancel that with r minus 3 on the bottom. And then we're left with r plus 7 over 4 times r plus 4, or 7. 7 times r plus 4. You might say, aha, I've got a 7 on the top and a 7 on the bottom. I can cancel those. You cannot cancel those. That's killing a kitten. The only way you could divide by 7 on the bottom here is if you had 7 in both of these terms, but you don't. You've only got 7 in one of those terms, so you can't just cancel it, right? Okay, so that was what your answer would be, but then you'd say where r, now what's r not allowed to be? I'm going to go back up to my original equation, and here's kind of the tricky bit here. Well, not tricky, but just something to remember. Just like before, you got to look at the denominator here. So I know that r isn't allowed to be negative 7, right? Because if it was negative 7, that would make that term equal to 0. R is not allowed to be equal to 3. But there's one more. R is also not allowed to be equal to negative 4. And you might be saying, well, why? Why can r not be equal to negative 4? It's in the numerator. You're allowed to have 0 divided by something, right? I can go 0 divided by anything. I can go 0 divided by 100. That's just equal to 0. So why is that not allowed? But here's the thing. You can't divide by 0, right? We're dividing. If this whole term became 0, then we would be dividing by 0, which you can't do, right? So you got to think about it a little bit different. So you can't divide by 0. So when you are doing these division questions and it says what are the non-permissible values, you are looking to see what makes the denominator of the original one equal to 0, and you're looking what makes the numerator equal to 0 as well. So I'd make yourself a little note there, or maybe circle that 4 or -4 to tell yourself where you got that from. Because you'd say maybe top can't be 0 when dividing. So that's pretty much it though. So multiplying and dividing are really similar to just simplifying. Other than that whole dividing thing, you have to just know about the non-permissible value thing and to flip it upside down. And then Okay, let's do number 11. So what I'm going to do first is I'm going to just factor everything. I'm going to leave it all the way it is, but just factor it first. So let's factor the top part here. So we're going to have m and m. And then needs to multiply to 54, add to 15. What about 9 and 6? And it'd be -9 and -6. That would work, yep. And then over. Now I can factor out a 9 and an m out of here. So 9m. And I'd be left with m minus 9. And then over on this side, I'm going to keep it as divided by. I can factor out a 9m squared out of this, right? At least I can take out m squared. And I'd be left with m minus 6. And then over, we're going to have is, I can factor out a 9 and an m. I'd be left with m minus 3. Okay, so that's kind of the tough bit. Now, all we got to do is just flip everything upside down. But notice I could cancel, like, you see here I've got like a 9 and a 9. I could cancel that right now because these are in the same term, right? They're like everything in here. I could just cancel like normal and then flip it after. But I'm going to go ahead and just keep everything the same and then flip it and then multiply. And then I'll start canceling stuff. I think that'll be an easier way to not make mistakes. One thing I just don't want you to do is say like, okay, I got a 9 up here and a 9 down here and cancel them. Because we're dividing right now, so you can't divide, you can't cancel those yet. So let's just go ahead and flip these. So we're going to write everything again. Do it in a different color. So we've got m minus 6 times m minus 9 over 9m times m minus 9. You're going to get used to writing everything over and over again. And then times, so I'm going to multiply now instead of divide. And now I'm going to flip these two. So we've got 9m times m minus 3 over 9m squared times m minus 6. Okay, moving on to the next one. This is actually the nice part about this. I don't know why you kind of like it. It's almost like popping a pimple or something. It just feels good to like cross stuff off. So we can start crossing things off here. Anything over top of anything else. So you can see I've got a 9m up here. And I've got a 9m down here. So I'm going to cancel those two. So they cancel with each other. I've got a m minus 9 up top here and one down there. So they cancel. I've got an m minus 6 over here and an m minus 6 up here. So they cancel. And that's about it. So all I'm left with after all that canceling is going to be just m minus 3 up top. And then 9m squared on the bottom. And that's my answer. But now we need to say where m, and now what's m not allowed to be? What are the non-permissible values? Look up to the original one here. And I'd say, okay, here, what is m not allowed to be? Because we can't divide by, right? Even though that's the first term, you can't ever divide by 0. So right off the bat, that m that I'm pointing to right there, that can't be 0. So 0, it can't be 0. Right here, it looks like m's not allowed to be 9, because if it was 9, that would make this term there equal to 0. So it can't be 9. If I look over here, 0 again. I don't need to write it twice. But it also can't be 3. So it can't be 3. But remember, remember the other thing that we were talking about here. When you're dividing by a different rational expression, the numerator can't be equal to 0 either. So it couldn't be equal to 0 again up top there, right? Because there's 0 squared to be 0. But it also can't be equal to 6. So there's a few non-permissible values here. I think that's it, though. So those are all our non-permissible values. M's not allowed to be any of those. Okay, so I'm going to let you guys do the rest of them. Pay attention to where it's multiplying and where it's dividing. And yeah, it's only the numerator that can't be 0 when you're dividing. So in this case, that wouldn't be the case. You're only going to look at the numbers underneath the bottom part of the fraction. Okay, so that's it for that one. Good luck on the rest of them.